Now that you have seen the thermal blade, I would like to take you through how I went about making it. Is that racist? I feel like that might be racist. Anyway, so first I modeled the thermal blade. I modeled it in Fusion 360. I'll go over that in a moment. I kind of sketched out a basic design that I liked, and then I went forth from there. Fun fact, originally I had designed the thermal blade, instead of working with LEDs, I had designed it to actually work with a piece of thermal wire that would actually make the blade heat up, and then I would have cut it out of metal instead of 3D printed it. Problem is, there is no way to fit the amount of power in the handle that I would have needed without it being like sword sized, and I really didn't want to have it have an external power cord running to something else. I thought that would have kind of looked stupid. So instead I opted for LEDs, and I'll go over some of my design decisions there. Next we print the thermal blade. After printing, we will figure out the electronics. Like I said, I had to refigure out the electronics since originally I had designed the thermal blade to work with actual thermal wire. But in this case, it's LED, so it's going to be run off of a little battery with a BMS and kind of control board built in that I took out of a battery bank, and I'll be retrofitting it into the handle. And then the color will be provided by LEDs. Luckily enough for me, this will also make the thermal blade internet accessible, so I'll be able to change the color if I want and turn it on and off with my smartphone. So that'll be nice. Then I will test fit, make sure everything works together, put everything together, make sure that it all looks good and plays nice with one another, and that the electronics work in the space provided. Then I will paint it and finish the assembly by putting everything together, make sure everything's all nice and sealed up, and that everything's working properly, then profit. And by profit, I mean enjoy my new toy that I made and now I get to play with. Alrighty, Roo, now that we're in Fusion 360, I'm going to go over a brief overview of how I modeled the blade and some of the decisions that I made. I'm not going to go in full detail because A, I'm not very good at Fusion. B, there are a lot of people out there that would explain how to do this much better than I can. And C, I would like to keep this video under some sort of time limit, and I would spend half an hour just fumbling over terminology. As I mentioned before, at first I was going to use actual thermal wire to make the blade light up, which I then discovered that I wouldn't be able to do because the handle would have to be at least 4 times the size that it was, and or it would have to have an external power source, and I think that would look gaudy. So I modeled this to be 3D printed on my Elegoo Mars because my TiVo Tornado is an FDM printer and my Elegoo is a resin printer. From what I've seen of transparent filaments are that they tend to yellow very quickly and they don't look as good and they're not as clear after they're printed versus the resin counterparts, which don't tend to yellow and they're much more clear. The Elegoo also has a much higher resolution, so there'll be less finishing work, and I have the red resin on hand to print these parts out. So kind of a kill 2 birds with 1 stone deal. I can make sure that the pieces are red and they look nice, and I won't have to spend 3 years sanding this thing. The first thing that I did was I took a picture of the thermal blade and turned it into a canvas, which you can see through the blade here, and then I kind of traced everything out, made sure my geometries were right, and I put in enough space for the battery and the LEDs to run through. They would go through here, they kind of wrap around the blade and then come back down. And I modeled this to be printed out handle, or there's a top and bottom, there's the handle, the ring, and then the blade. Unfortunately though, this particular model was too small. I printed it out here and it looks it looks pretty darn good, but it's too small to fit my battery and the controller boards that I need. I also had some of the pieces like this outer blade here. This was one piece, and then it had several pieces here that kind of went into it. And I found that to be way too brittle, so the pieces kind of snapped off, and it just wasn't a good time. So I went back to the drawing board, and I made this one. Now, some of the benefits of this model, it does look a little bit chunkier there, but I'm sure it'll print fine. Some of the benefits of this model are that it is larger, because I printed the handle and the blade out in two separate pieces with a top and bottom, so I guess that's technically 4 separate pieces. And all of the pieces will separately fit on the print bed of my Elegoo Mars. I also combine the tops and the bottoms of the blade here, so instead of this being a piece, this being a piece, this being a piece, and this being a piece, this is all one piece that prints all together. That should provide me with a lot more structural stability and a lot less finishing work in the long run. So from here, I just exported the files to Chidubox, I think it's pronounced, and then I ran them over to my printer and hit print and printed all the pieces separately. I would show you a time lapse of it printing, but it's on the resin printer, and I'm not going to put a GoPro in a vat that's basically sealed with a bunch of resin. That can't be good for the electronics. So I'll show you the pieces after they're done printing. See you soon! Now the pieces are done printing, and they look amazing! Well, most of them do. Most of them look immaculate like this, but there are 2 of them that came out kind of wonky. The bottom part of the blade here on the back side, as you can see, it's missing like this little pointy bit here. It kind of bowed over for some reason, and this bit broke off. And then the top part of the handle ended up all round, and this part kind of broke off from the rest of it. It printed more rounded for some reason, and it caused some issues. But no big deal. I mean, if that's the biggest thing I run into in this project, I'll call it a win. So what I'm going to do now is I'm going to go in and reprint these 2 pieces, and then I can get on with the sanding and the painting and the fitting the electronics and such. See you soon! Cut to the next day, and the part goes from looking like this to looking like this. Much better, I know. I reprinted this on my Elegoo Mars. Same procedure as the other one. I held off on reprinting this part of the handle because I think I might have a trick up my sleeve to save it. So if I don't have to spend at least 5 hours oh no, I think this one takes 8. Well, at least 5. So if I don't have to spend at least 5 hours reprinting it, I'm not going to, if I can save it by other means. From here, I'm going to run these through the grits. Like I said before, I don't think that they'll need a whole lot of sanding. I'll probably just go up through, do 80 grit, 120, 200 if I have it, and then 320, and I think that'll be more than enough for the detail that I'm trying to achieve on these parts. But from here, I'm just going to sand these down, and before I worry about painting anything, I'm going to make sure they're nice and smooth, and then do a bit of a rough assembly so that I can make sure all the electronics fit, and then I'll go from there. I suppose now's as good a time as any for this safety warning. Anytime you're working with resin, like I am about to do and have been doing, you want to wear nitrile gloves and a face mask. There's a lot of debate about whether or not it's safe to handle and everything like that, and there are a subset of people that don't think it's unsafe, but that's largely because we don't really have enough data to know if it's super unsafe or not. But better safe than sorry. So after several hours, I finally finished sanding all the parts, and they look a little something like this. Well, that sucks. Why does this always happen to me? Yeah, oh, this one too. Okay, yeah, I'm gonna get these off of my table before I... Yeah, I broke it. I glued it to the table, and then when I tried to pick it up, it just snapped right in two. Well, technically it snapped into multiple pieces, but... yeah, I'm thinking that's a little too brittle for me to work with. Well, that sucked. I don't know if you saw it in the video there, but I managed to break it yet again, and that was after breaking... Where'd it go? After breaking this part of the handle as well. You can see where it's super glued there. Which it's 110% my fault. I shouldn't have been gluing it on my table. I shouldn't have been so hasty. And then, you know, when I picked it up, it just... I should have been paying more attention. That one's on me. The only option that I can see that I have left now is first to scrape the other piece off of my desk, and then I'll have to scrap the entire thing, go back to Fusion, model it in 2 separate pieces, buy some clear filament, and then print it all in 2 separate but equal pieces on my TiVo Tornado, and just hope that clear filament will, you know, look decently. Originally, I didn't want to do clear filament because most of the ones that I've seen don't really look good, but at this point, this is my last option, and if that doesn't work, then this will very well be a video on how not to make a thermal blade from Subnautica. So, let's hope beyond all hope that the TiVo route works. I really need a win on this project. To Amazon! After what happened last time, I did a bit of a rethink and redid my STL again, and then reprinted it. This time I beefed it up in some places and kind of moved some things around. So hopefully that wouldn't happen again and it would better accept the LEDs that I have for it. And I came up with this. I went ahead and I glued these together off camera because, I mean, you've already seen me do it once. You don't really need to watch me do it again. And it didn't come out perfect. Like on this one, it's got some schmutz on the end here that I'll have to file off. But overall, the lines came out much better on this version. And it fit together much better since this is in a total of 6 pieces instead of 12 pieces. All that's left to do now before I can finish this thing, I've got to sand it, I've got to paint it, and then it's on to final assembly. I cannot wait to see how this thing turns out. Okay, the paint's finally done. It's not perfect, but it is something that I can be proud of, and I think it looks really nice. And like Adam Savage says, the enemy of the done is the perfect. So I think that this is good enough for my purposes. Some of you will notice that I did change the ring from blue to red because I like the red, white, and black color aesthetic much better than I do the blue. And I mean, hey, creative licensing, right? All that's left to do now is I have to solder up and run the electronics and stick this sucker together, and then I will finally be able to see what it looks like all lit up. I cannot wait. I'm so excited. Yeah. Now, if you put it all together and you're really, really lucky, it ends up looking like this. What? I didn't say it was gonna be good luck. In fact, the luck was quite bad. I had just finished the thermal blade. It was painted, it was printed, it was well designed. I put in the battery, wired up all the electronics, put the LEDs in, glued it together, and I was in the process of moving it somewhere else so that I could get some final pictures and some B-roll for the end of the video, and I dropped it. I dropped it. I put my foot down to try and catch its fall, and that just ended up hitting one end of the knife, causing it to like spiral. It hit the floor, and it shattered. I was absolutely gutted when that happened. So the way I see it, I have two choices. A, I can spend another month redesigning it to be stronger, even though, I mean, it probably doesn't need that anyways. It's not exactly it's not exactly meant to be something that's going to actually try to cut through something else. It's mainly meant to go on a wall and light up and look pretty, and that's about it. Or B, I can revel in the fact that I finished it, it's done, or was done, and move on from here to my next big project and just take the lessons that I learned on this one and apply them to my next project. I think I'm going to go with B, because even though I don't have the finished project anymore, I threw all the pieces away once it shattered, I still, it's not something that I want to make again. It's not something that I really have the time to make again, and you guys can still learn some lessons from me in watching this video. Now, doing this taught me quite a few things, and I'm going to go over some of them, and hopefully you guys learn something from this, and you'll be able to apply that to your projects. Number one, it's okay to move on. Now, I was gutted when I dropped the sword. I was gutted when I dropped the blade. But at least I got it finished. I got to see the finished product and see it light up. I just wish that you guys had been able to see it light up and everything. But at the end of the day, I set out to make the thermal blade. I made the thermal blade, and now I'm going to move on. Because I really... I don't feel like investing the time, effort, or money into redoing it, especially since it was like a one-off anyways. I think that I can be proud of what I made, and I can live with the memory of the product before it shattered, like 15 seconds after I finished it. Number 2 is knowing when to stop. I had a lot of issues with this blade. I wanted to do it with some actual heating wire that wrapped around the blade and put a battery or power source in it so that the blade would actually glow red and be able to burn things. That would have presented quite a few different challenges, like I would have needed a metal blade, and ultimately I ended up not going with that because the power source needed to make the blade glow red. I wouldn't have been able to fit it in the handle. It would have had to have had some type of like external power supply, and I really didn't want that. I wanted to be nice and clean. So instead I settled on LEDs, and then I made a few more compromises along the way, and I think it's like Adam Savage says, the perfect is the enemy of the done. So one of the reasons why this took me so freaking long is I went through and I kept making little changes here. Ooh, I can make it better this way, and I can make it better this way. And there's, in a sense, there's nothing wrong with that. There's nothing wrong with wanting to make the best thing that you can make and trying to make it as well as you possibly can and out of the best materials, etc., etc. But at some point, you really gotta learn when it's time to say, okay, I've done the best that I can do. Maybe I revisit this later when I'm a better maker, or when I have better tools, etc. And I'll use what this taught me on future projects. This also made me much better at Fusion 360. I mean, out of the 4 months that I spent making this blade, probably a solid month of that was designing, redesigning, doing little tweaks here or there like you saw at the beginning of the video. Just really dialing things in and becoming better at my chosen program that I use to model things. This also gave me an opportunity to get better at painting and electronics. Both of those were far from perfect in this video, but it did give me a chance to practice, which I'm grateful for, and it made me that much better at it. In the future, when I have to paint something or run some electronics, I will be able to apply what I learned from the blade on it, and that will help me in the future. And the biggest thing that I would like everybody to take away from this is that accidents happen. I used to be the kind of person that would beat myself up royally over, I screwed this up, or I didn't do this way, or I said this instead of that, or I could have done this, I could have been there, whatever. And honestly, there's really, really no point in doing that, because 9 times out of 10, there's nothing you could do, or it wasn't your fault. In this case, I dropped it. It happens. And although it would have been nice to put on my wall, no matter what happens, things have a way of working themselves out in the end, and there isn't really any point in beating myself up over things that I can't control, or worrying about things that are that I could do nothing about. Don't beat yourself up when you screw up. The best thing to do is just to look forward, learn from your mistakes, and fix them or apply your knowledge in the future. And that was something that hit me really hard with this one. I mean, that's 4 months down the tube. But I learned things on it. I know that even though I dropped it, there's nothing that I can do about it now, and the best thing to do is to move forward and get on with other projects. So there you have it. There's how not to make a thermal blade from Subnautica. I know that this took way too long, but I really hope that some of you have seen this video and have gotten inspired to do something yourself, hopefully not dropping it at the end, running the whole thing, or that you've learned something from my successes and failures on this project. I love seeing people inspired to make things and to do better than they were before. But that's the end of this video. So if you liked or disliked it, then you know what to do. If you have any questions, comments, concerns, leave them in the comment section below. I want to thank each and every person that watches this. It helps alleviate the sting of it shattering. And I really do hope to see you all in the next video. Bye!